we're starting our unit on gases, and as we talked about in class, we have to measure the pressure of gases sometimes, and there's a whole bunch of different units that we can use to measure the pressure. So what that means to us is that we need to be able to convert back and forth between these different units. So what I want to show you today is how you can do that. And it's a pretty easy process. You just have a certain number of steps that you have to kind of keep straight. So what I've got on the board here are the different units that we use to measure the pressure. So we use atmospheres. ATM stands for atmospheres, and at normal sea level, kind of typical day, the pressure in the air would be 1 atmosphere. Now 1 atmosphere is equal to 760 millimeters of mercury, 101,325 pascals, 101.325 kilopascals, and 14.7 pounds per square inch, or psi. So all these units are equal to 1 atmosphere, which means they're all equal to each other. So it's relatively easy to solve these problems if we use ratios. So I have 3 problems on the board here that I'm going to solve, and I'll show you how to do that. So the first one, we want to take 2.5 atmospheres and convert that into millimeters of mercury. So what I'm going to do here is set up a ratio of atmospheres to millimeters of mercury, so I know what the ratio ought to be. And I'm going to get that from this list. I'm going to say 1 atmosphere is 760 millimeters of mercury. So those 2 units are always in the ratio of 1 to 760. So on the other side, we're going to need to have the same ratio, just with different numbers. This time I have 2.5 atmospheres, but I don't know how many millimeters of mercury I have. So that's our unknown, that's our x. So if you remember your algebra, what you have to do here is cross multiply and then solve. So 1 atmosphere times x, that gives us x. And then 2.5 times 760, so that's where the calculator comes out. And that's 1976. So that's our answer, but before I put it on the line, I want to think about significant figures, and I only want 2 of them. So that would mean rounding up, which is going to be a problem for us. So right away, I'm giving you a hard one to round up. And the only way to get 2 significant figures on this is to put it in scientific notation. So I'll do that and say 2.0 times 10 to the 3rd millimeters of mercury. Now let's go on to the next one. We'll use the same strategy. We have to get from psi to kilopascals. So I'm going to set up a ratio using the numbers that I know are correct ratios. So we know that 14.70 psi is equal to 101.325 kPa. So on the other side of the equal sign, I'll take the numbers that are given in the problem, and that is 12 psi and x kPa. So again, I'm going to cross multiply 14.7 times x equals 12 times 101.325. Can't do that in my head. And that gives me 1215.9. Now that's way too many significant figures, but I'm just not going to worry about that until the end. So to solve, I've got one more step this time. I'll have to divide by 14.7. And that gives me 82.714. So how many significant figures do I want to keep over here? Only 2, so I'll call this 83. And I'm going to stop and do a little sanity check here for a minute and say that 12 psi is a little bit less than an atmosphere. So I kind of want this to be a little bit less than an atmosphere also. and it looks like it is. So it looks like it's in the ballpark, so I probably did the problem right. It's always good once in a while to stop and do what we call a sanity check. All right, let's do one more. So down here I've got 125,000 pascals, and I want to convert that into atmospheres. So I'm going to go over here and get my numbers. 120, whoops, that's not what I meant to do. So pascals is 101,325, and 1 atmosphere. So those are my standard numbers. I know that's the ratio that I need. And then in the problem, I'm given the 125,000 pascals, and I want to know how many atmospheres. Now, by the way, right here, let's stop for a second and say it would be perfectly fine if you decide to put atmospheres on the top of the fraction and pascals on the bottom. You will still get the same answer. So as long as you keep your known values on one side of the equal sign and your problem values on the other side. So on one side of the equal sign, you need to take the numbers from the box. And from the other side of the equal sign, you need to take the numbers from the problem. It doesn't matter which side of the equal sign, you probably know that. And it doesn't matter whether you put pascals on the top and atmospheres on the bottom or vice versa. You'll get the same answer no matter how you set it up. All right, so let's solve this. We've got 1 times 125,000 equals 101,325 times x. So to get my answer, I'm going to have to do division. All right. So this should be 1.233. And over here I've got 3 significant figures, so that becomes 1.23. And that's my final answer. So I hope that was helpful. Good luck on your homework.